This video is for introduction for our project Automatic Statistician. So the goal of the project is to evaluate quality of dataset with respect to statistical parameters and analyze the pattern between dataset popularity with respect to the statistical quality. So this goal raises the problem of what is meant by a good dataset. Is the dataset just good because we like it, or is the dataset good because it contains rich information? And second, what is meant by a fake dataset or fake data? What if the dataset follows some kind of simple model very well, or what if the nature of the dataset follows the rules very well because it reveals some like simple physics relations. One inspiration of the project actually comes from the idea of Sloan's gap. So there's a personal or more preference on what kind of series people like to research, and we can borrow this idea to ask what moral influence on what kind of data we like to people like to do research on. So we define different kinds of matrix. So first is the non-statistical parameters, parameters not related to any statistical quality. So number of observations, number of variables, and so on. And we are interested in the the shape of the data. So the distribution, does it follow normal distribution? Because if you follow normal distribution, then a lot of statistical traditional statistical method can be used, and also different criterias. Also, we are interested in whether the dataset has a lot of linearly dependent, linearly correlated variables, because if some linear component can represent a lot of variations in a lot of columns, then the dimension can be easily reduced. Also, we are interested in the form, because sometimes the dataset is simple, but it's not linear. If there's a curve or some curved distribution, we can also detect it with smooth function and also the predictive functions that uses the distance as a component. So this can let us decide whether this dataset has a folded curve or not. Also the complexity in terms of fractal dimension and entropy, because these are like how complicated the dataset is. How does it have complex structures inside, and also predictability. We can ask, is it possible to build a robust model on it with maybe other machine learning method? So you could use those methods as use the performance of these models as a matrix. So the implementation of the code, you could see the Python notebook file. We skipped the fractal dimension part because it's too slow and did not finish running. Then we analyzed the result. It turns out lots of by a pairwise analysis, lots of points, lots of metrics are not directly related to the popularity, but the number of eigenvectors needed to represent certain variance in the dataset has a negative correlation with the popularity. So if you look at the last two columns, the number of hits goes down if you need more proportion of eigenvector to represent a variance, And also, paper citation has some kind of relationship with the performance of the low-S smoother. This is our. We also did the identity plot, but there's like we are running out of time to more complicated analysis. Thank you for watching the video.